All right. So we're comparing figure 1 and figure 2. It's the same object, but there is a change in the force. And these are force vectors. So the first thing that you need to do is determine both the x and y components of all the vectors and then add them up. So one way to do that is just write them out. So this one here, let's assume this is the origin. It's 0, 0. My x component to the right on this one is a positive 1 x hat. Whoops. We seem to be running into some sort of delay here. Okay, let me close this. Maybe this is the issue. That's in the x direction. And then my y direction, it's a positive 3. Now what that means is from here, I went to the right 1 unit and I went up 3. Now over here, I went to the left 3, negative 3, x hat, minus, and I went down 1. And it's really just the coordinate points, right? If I go tip to tail, right, from this one. And then this last one is just going to be, we go to the right 2, so it's positive 2 x hat plus 2 y hat. So then what I do is I just add up all the x components. I've got 1 plus 2 minus 3 is what? So if I add 1 plus 2, and then I subtract 3, what do I get? 0. So that becomes 0 x hat. So there's no motion in the x direction. Okay? Because my net force in the x direction is 0. Now let's look at the y's. I've got 3 plus 2, that's 5, minus 1, that's a positive 4. So there is motion in the y direction on figure 1. Okay? So one of the options was, let me just double check the math on this all just to make sure. I went up 3. Oh, you know what? I did make a mistake. It's not plus 2, it's negative 2, isn't it? Yeah. So I knew that there was no motion, and I was like, well, where did I screw up? So negative 1 and then negative 2 equals negative 3, and then when you add 3y to it, so the resultant vector is 0 plus 0 y hat. So this means that I have a 0 net force in the x direction and a 0 net force in the y direction. Now let's go over here and do the same thing for figure 2. It's the same object, but now the forces have changed. So this one has a 0x component, right? And it goes up 3, so that's plus 3y. This one goes to the right 3, and you guys double check because I'm trying to hurry up and get this done before the bell rings. And it goes down 1, so technically that should be a negative. Negative 1 y hat. And then from here to here, I've got negative 2 x hat, and then I go down 2. So now if I add those up, I have 1 x hat, right? 0 plus 3 is 3 minus 2 is 1. And then positive 3y minus 1 minus 2, that's 0 y hat. So now, because I have a net force in the positive x direction, but 0 net force in the y direction, the object is now moving in the positive x direction. So if I were to summarize this, because they want us to determine, compare and contrast figure 1 to figure 2. So for figure 1, there's really no change or no motion because the net force in both the x and y direction is 0. But for figure 2, we have motion in the, let me see how they worded it. Motion in the x direction, changing in the x direction. Yeah, not changing. So they worded it as changing in the x direction. Okay, did that help? Now you don't have to, you almost have to do the numbers to make sure, but you don't. You could literally count that in your head if you wanted to, but I like to write it out. Okay, all right, is there any, does that make sense the way I did that? Okay.